Okay, so this is your unit circle packet, and what we're going to start with is filling in the degrees, which is the inside part, and then the radians, and then the ordered pair. So 0 degrees is the same as 0 radians, which is 1, 0. The other blanks for this is if you loop around, it'd be 360 degrees, which is 2 pi. And I'm going to go ahead and label my quadrants. I'm going to put 1, 2, 3, and 4. So this is going to be one of your main reference sheets for when you're doing your review and test. I know you'll already have a copy that's already filled out, but it'll help you remember it more if you write it in again. So the next one would be 30 degrees, which is pi 6. And that ordered pair is square root of 3 over 2, comma, a half. 30 degrees, pi 6, and square root of 3 over 2, comma, 1 half. So then the next one would be 45 degrees with pi 4s. And that's the square root of 2 over 2 for both x and y. And then the next one is for 60 degrees, which is pi thirds. Now on that one, what you do is you reverse your coordinates for the 30 degrees. So it's 1 half and then square root of 3 over 2. Okay, so far you have your 0, 30, 45, and 60 information. The next part would be your 90. So 90 degrees, which is pi halves, and it's 0, 1. Again, if you want to go faster than me, you can. Now, the part you don't want to forget to do is the positive and negative for each of them. So the positive for this quadrant would be all, and the negative would be none. Okay, so that means your sine, cosine, tangent, cosecant, secant, cotangent are all positive here because you're in quadrant 1. Now, the next angle would be the 120 degree angle, which is 2 pi thirds. And that ordered pair, how you can remember it is you look at the pi thirds ordered pair, so you know it's going to be based on the 1 half and the square root of 3 over 2, but you're going to make your x negative. So you're going to take this half and bring it over and make it negative. And then still positive square root of 3 over 2. And then the next angle that we're interested in is 135. And so that'd be 3 pi 4s. So you look at the 45 degree one, which is square root of 2 over 2 for both, and you just bring your x over, which is negative. So negative square root of 2 over 2, and then positive square root of 2 over 2. Because again, remembering where you are, your x's are negative, your y's are positive. Then our next angle is 150, which is equivalent to 5 pi over 6. And you look at your pi 6, which is square root of 3 over 2, and then a half, so it'll be negative square root of 3 over 2, and positive a half. And then this ordered pair is negative 1, 0, which is pi radians and 180 degrees. Negative 1, 0 is your ordered pair, then pi, and then 180 degrees. Now the part for the positive and negative for this one, it looks like your x's are negative, so anything with only your y values would be positive, which is your sine and cosecant. Sine and cosecant are positive. And the others are negative, which are cosine, secant, tangent, and cotan. So I'm just using the 3-letter abbreviation. Sine, cosecant are positive because those relate to the y value. If you remember, x comma y relates to cosine comma sine. So the first letter is x, and so that corresponds to cosine, which c comes before s. It's an easy way to remember it. So your y's are positive since you're above the x-axis. Now for this part, you're going to 210 degrees, which was equivalent to 7 pi 6. And that ordered pair would look like the one above it for 5 pi 6, but make it a negative a half. So negative square root of 3 over 2, negative a half. So one of my goals on this exercise is to get you to know, if you remember the first quadrant, you can figure out everything else. Because just the numbers stay the same, but where you are changes. We're in quadrant 3 for this one, so both have to be negative. The next one after 210 is 225, and that'd be 5 pi fourths. And that one is negative square root of 2 over 2 for both. And then after that is 240, which is 4 pi thirds. So that's negative a half, negative square root of 3 over 2. So this time, the only positive ones are when you're dividing either y divided by x or x divided by y. So that'd be tangent and cotangent. And then all the others would be negative. So cosine and secant are negative, and sine and cosecant are negative. And then your next one, it's 270 degrees, which is 3 pi halves, and that's 0, negative 1. Okay, again, working our way around. After 270 is 300, and so that'd be 5 pi thirds. Which is the ordered pair that corresponds to this, except for you have a positive half. Or you can even think the one that corresponds to the pi thirds up here, but then you just change your y value to negative. So you've got a positive half for x and a negative square root of 3 over 2. Then your next one is 315. Which is 7 pi fourths. So again, it's based on a 45-degree reference to the x-axis. And this would be square root of 2 over 2 for one of them that's positive, and then the negative y value that's the same number, negative square root of 2 over 2. Then your last one is 330 with 11 pi 6, and so that'd be square root of 3 over 2, like the one above it, but then a negative a half. And that's quadrant 4. So the ones that are positive are the ones relating to x, So that'd be cosine and secant. And the negative ones would be the y values, which are sine and cosecant, as well as when you're doing y over x or x over y. So tan and cotan. Does anybody need me to go back up to the top half? Okay. All right, so that's your unit circle. Now, I realize this is a big packet, and special right triangles, this is something you need to know for college readiness. You don't have to write this part, but college readiness, SAT, ACT, if there were like a STAR test on pre-cal, this would be on it, and also on a geometry one. So what we're going to do on this is the evens, and so we'll go through these together. At this point, there's not any Math Excel just on this, because I know this is something you haven't done recently. But again, because of college readiness and it's related to right triangles, I wanted to go over it. Now, the number one thing you're going to need to remember about this is there are certain patterns for these, like for the 45-90 right triangle, the pattern is x, x, x squared of 2. I'm also going to put that in a list. So under the 45 is x, under the other 45 is x, and then under the 90 is x squared of 2. So in the same way on the picture, however it's oriented, across from a 45 degree angle is x, across from another one is x, and then x squared of 2. You know what, just learning from example, I'd rather you change x to s, if you don't mind. Because some of these, when I first went through it, I was looking at a's and b's over here, but then it also has x's and y's, and so it's going to make more sense if you put s. Sorry about that. Okay, so those are S's for side. Okay, so that's your 45, 45, 90. Now for your 30, 60, 90, make one taller than the other. So in other words, on your first triangle, these should have looked the same size. But on this one, you've got your 30, 60, 90, and it's S, S squared of 3, 2S. So we can put 30, 60, 90, S, S squared of 3, 2S. So in other words, your side that's 90 is twice as big as the one for your 30 degrees. One way to remember the order of it is your square root one for this one has to be in the middle, because the square root of 4 is 2, and so the square root of 4 would have to be after the square root of 3. So those are your patterns. Okay. Now, for problem 2, we've got 45 there, which means 45 has to be up top. And it's S, S, S squared of 2. So there's two different approaches to this, which are both good. One is just to draw your pattern on here and then set it equal, like S squared of 2 equal 4, and then solve. Your other approach would be to make a table like 45, 45, 90, S square root of 2. And in your case, across from the 90 is 4. And so you'd put a 4 here and put a box around it because it doesn't change. So in either case, you're setting S square root of 2 equal to 4. And so then you have to solve for S by dividing. And so 4 divided by square root of 2. When you rationalize that by putting the same thing on top and bottom, the square root of 2 over square root of 2, you get 4 square root of 2 over 2, which is 2 square root of 2. So in other words, the shortcut is if it's even on top, then just divide and then put square root of 2. So 4 over square root of 2 becomes 2 square root of 2. And so 2 square root of 2 would be our answer for both x and y. So in this case, you've got 2 square root of 2, 2 square root of 2, and 4. 4 is your hypotenuse. Sometimes you might have both of these as whole numbers and one of them as a square root. But in this case, we have 2 of them that are square roots and then the other is a whole number. Any questions? Okay, now on this one, that's 45, so is this. I'm just not going to label it. And so if that's 3 square root of 2, so is this. So that's one of our answers. Now, the hypotenuse is going to be the same number with an extra square root of 2. Remember, the pattern would be S square root of 2. So this is going to be 3 square root of 2 followed by another square root of 2, which is weird. You can think 3 square root of 4 or just 3 times 2, and you get 6 for your hypotenuse. So you have 2 that are the same, that are across from the 45-degree angles, and then your whole number is 6 for your hypotenuse.
Are we going to see this on like a math Excel or like a test?
You probably would see it on an SAT or ACT. I'm kind of doing this for college readiness. It's not going to be on the current Math Excel for 6.2. Yeah, it won't be. I'm kind of reviewing it because I know that some people are going to take the SAT and ACT again soon. And I also know they have something like this in college algebra. So I'm kind of reviewing it because y'all probably haven't had this since probably your sophomore year or maybe your freshman year. So that's why. Yeah, good question. Now, this is one of the trickier ones, number 6, because instead of saying square root of 2, it says square root of 6. So what we do is we actually just rework it to make it have square root of 2 at the end. And so that'd be 2 square root of 3 square root of 2. So you think about 6 is 3 times 2, right? And so that means I can take this 2 square root of 3 and that'd be these answers. If you'd rather see more work for it, you could say S square root of 2 equal 2 square root of 6, and then divide it out. And so you get S equal 2 square root of 6 is really square root of 3 times square root of 2, and then those cancel. So that's how we ended up with 2 square root of 3. Okay, so that's a refresher on some of the 45, 45, 90s. Any questions? Okay, so number 8, this one is a 30, so we got 30, 60, 90. So that pattern was S squared of 3 that's across from 60 and 2S. And again, if you'd rather write your pattern to the side, you can. I can't say it's a formula because there's no equals. So this is your pattern. What I remember some people saying, in geometry one year was like, why can't we just do the Pythagorean theorem? And that's a good question. The reason why you can't is you only know one number. You have to know 2 numbers in order to do the Pythagorean theorem. Yeah. So if you've got 2 under the 30, I put a box because I can't change to anything. And then that means this would be 2 squared of 3, and then 2 times 2 is 4. So 2 squared of 3 is this answer, and 4 is this answer. Okay, so that's number 8. Number 10. On this one, you've got 60 degrees shown, so we know this other has to be 30. And so we're going to do 30, 60, 90, S squared of 3, 2S. The S is always the one that's across from the 30-degree angle. So if it's across from it in the triangle, then it's across from it in the column. And then the 60 is this one, and the 90 is that one. Now again, this one's a little trickier than some of your basic ones because this has square root of 5, not square root of 3. So what we do is we put the one across from 90 is 8 square root of 5. And I put a box around it because that can't change. And we say 2s equal 8 square root of 5. Then we divide by 2, and so that'd be 4 square root of 5. It doesn't turn into 5 halves for your square root part. The square root thing itself protects it. If you want to check that out on the calculator, let's see. Just to show you how things work. 8 square root of 5. Okay, on the CX2s, if you just press enter, it's just going to put the same thing there. So you really got to put control enter to make it a decimal. And if we want to divide that by 2, we get that number, 8.94. So it's not 4 square root of 2.5. That's not going to match. It's 4 square root of 5. So that's the 8.944, so forth. So that's the way it works. So this is 4 square root of 5, and then you got 4 square root of 5 followed by square root of 3. If it follows it like that, you got to multiply them. So this is going to be 5 times 3, which is 15. 4 square root of 15. So one of them is 4 square root of 5, and the other is 4 square root of 15. and the final one was 8 square root of 5. So that's probably our hardest one today because all three were square roots. But yeah, y'all need to probably hang on to this sheet when you take your college algebra class and use it for examples. Okay, number 12, you got 30 here. So 30, 60, 90, s square root of 3, 2s. Across from the 90 degree is 10. Bless you. And so if we have 2s equal 10, then s is 5. So this ends up being one of the easiest ones. So you get 5 and 5 square root of 3. So you have 2s equal 10, so you take half of that, and that means your shortest side of the triangle is 5, and then the medium one is 5 square root of 3. So what 5 square root of 3 looks like as a decimal is 8.66, so that's how you know your hypotenuse is bigger. Your 10 is bigger than 5 square root of 3. The thing about these type problems is they don't want any decimals. So that's why it's a little bit trickier. Okay, then number 14, if that's 30, then this is 60. And you've got 30, 60, 90, s square root of 3, 2s. So across from 60 is 12. I wish across from 90 was 12 because that'd be easier, but it's not. Across from 60 is 12. So then we've got s square root of 3 equal 12. And then we divide. And then when you rationalize this, this turns into 4 square root of 3. And then the other 4 square root of 3 times 2, or 2 times 4 square root of 3. So that's 8 square root of 3. Now, remember when you're doing these, you don't multiply your 2 times whatever's underneath the square root sign. It doesn't work that way. It's not like distributing. There's no plus or minus, so that's why you just multiply the front. So you should get 4 square root of 3 for that one and 8 square root of 3 for that one. Okay, number 16. If that's 30, here's 60, there's 90. So 30, 60, 90, s square root of 3, 2s. And across from our 60 is 11 square root of 3, which makes this an easy problem. If we're expecting s square root of 3 and we have 11 square root of 3, then we just know automatically this is 11 and this is 22. So just think about it being a pattern. If it's s square root of 3, then just take off the square root of 3. And it's like the easiest type problem. So again, some of them are really, really easy. Some of them are really, really hard. Just depends. And then number 18, this one, if you got 45 there, you got 45 there. So 45, 45, 90, s square root of 2. So again, make sure you know your pattern out of everything. The square root one is in the middle for the 30, 60, 90, but the square root one is at the end for the 45, 45, 90. So don't get those mixed up. And then what we have as across from 90 is 7. So you put a 7 here, put a box, because it doesn't change to 7 square root of 2. And this one we divide by square root of 2. And then we rationalize. So that again means same thing on top and bottom. And so if you're like one class, you have 7 square root of 2 over 2. But the other way is just put 3.5 square root of 2. So your whole thing cannot be a decimal, but your like coefficient, if you will, could be. So either of these would be acceptable for M and N. Okay, so again, that was pretty much a review. You won't see this on Math Excel. I just wanted to go over it with you for knowledge, for college readiness. Again, if you need to go back in the video for this part, you can. And let's continue on the next ones. Okay, now this is more degrees versus radians. And so for this, sometimes they're just going to show up on your unit circle and they're going to be really fast. Sometimes you're going to have to actually do your conversion. Let me show you how to do your conversion.
Are any of these from this worksheet?
This is from 6.1.
Like they're going to be on, any of them going to be on Math Excel for 6.2?
For 6.2, no, but for 6.1 it was.
Okay.
Yeah. Yeah, so good question. Now this one, remember you're going from degrees to radians and radians to degrees. So this one, you had your pattern where you multiply by pi over 180 when you're going degrees to radians. So as a reminder, what we did was on your calculator you type 45 divided by 180 and you get 1/4. And so then your answer is pi fourths. That's what we did before on 6.1. If you have degrees, then you're multiplying by pi over 180. So you do the number parts as a quotient or ratio, reduce it, and then put pi on top. Now, the reason why I'm going back to this is there's a lot quicker method. If it's 45 degrees, why don't you just look at your unit circle and see it's pi fourths? That's your answer. So with the unit circle, it's a lot quicker on some of these. Okay. Now this one's pi 6. If you don't have your unit circle and you're going radians to degrees, you'd multiply by 180 divided by pi, so your pi's cancel, and you get 30 degrees. Or again, why not just look at your unit circle? Pi 6 is 30. Okay, so I've done a couple of them this way. Now, when they show up on the unit circle from now on, I'll just look at the unit circle to save work. 330 is 11 pi over 6. So you just find it. 3 pi over 4 is 135 degrees. Two pi over 3 is 120 degrees. 270 is 3 pi over 2. Now, 10 pi over 3 doesn't show up here. 5 pi over 3 does. So this one, most students don't just like counting. I'll show you how that works, but most students don't like this way. We're going to 10 pi over 3. So here's 1 pi over 3, 2 pi over 3, 3 pi over 3 is pi. 4 pi over 3, 5 pi over 3, 6 pi over 3 is 2 pi. 7 pi over 3, 8 pi over 3, 9 pi over 3 would be 3 pi, and then 10 pi over 3 would be right there. So most students don't like doing it that way, and I get that. I mean, it's kind of complicated, especially if you end up counting by 6s instead of 3s. So what we would do is we just use our formula from earlier, and we've got our 180 on top and pi over bottom. You cancel them out, and so then you just do 180 divided by 3. Well, we know that's 60, right? And so then you get 600 degrees. Okay, and then our last one is 225 degrees. We can just look at the unit circle for that. And 225 is 5 pi over 4. There was one other way on 7. You don't have to write it, but you could have found the coterminal by doing 10 pi over 3 minus 2 pi, which means 10 pi over 3 minus 6 pi over 3. And then that's 4 pi over 3. And 4 pi over 3 is 240. This is a long process. And then add 360. And you get 600. Okay, so you don't have to do it that way, but it does all work out if you do that. That's going to be our stopping point for the day. We'll continue with this tomorrow.